In the last video, we learned what a process is and how the operating system manages multiple processes. But now a new question comes up. How does a program actually talk to the operating system? For example, how does a program read a file, print something on the screen, or create a new process? It turns out programs cannot directly access hardware or perform sensitive operations. Instead, they use something called system calls. A system call is like a special function that allows your program to request services from the operating system. You can think of it like asking the OS for permission to do something. For example, if your program wants to read a file from disk, it cannot directly access the disk. It has to ask the operating system using a system call. Now here's an important detail. System calls run with higher privilege. That means they have more power than normal functions. They can access hardware, manage memory, and perform operations that regular programs are not allowed to do. Some system calls can also block a process. For example, if your program asks to read a file, it may have to wait until the data is ready. During this time, the OS can pause that process and run something else. Now you might be thinking, do we have to write system calls directly in our programs? The answer is usually no. Most of the time, we use high-level functions from libraries. For example, when you use printf in C, it internally uses a system call to write to the screen. So the library hides the complexity, and you don't have to worry about it. Another important thing is portability. Different operating systems may have different system calls, but most modern systems follow a common standard called POSIX. This allows programs to run on different systems without major changes. Now, let's look at some important system calls related to processes. There are 4 key ones you should know: fork, exec, wait, and exit. Let's start with fork. Fork is used to create a new process. But here's something interesting. Every new process is created from an existing process. There is no way to create a completely independent process from scratch. So when fork is called, the OS creates a child process by copying the parent process. This means the child starts with the same code and data as the parent. After fork, both parent and child continue execution from the same point. But they are now separate processes. They can run independently and modify their own data. Now comes an interesting part. How do we know which one is the parent and which one is the child? The fork function returns different values. In the child process, it returns 0. In the parent process, it returns the ID of the child. This allows the same code to behave differently in parent and child. Now after fork, both processes are running the same code. But what if we want the child to run a completely different program? That's where exec comes in. Exec replaces the current process with a new program, so the child process can load and run a different executable. After exec, the old code is gone, and the new program starts running. This is how most real systems work. Now let's understand wait. When a parent creates a child process, it may want to wait until the child finishes. This is done using the wait system call. When the parent calls wait, it pauses until the child process completes. Once the child finishes, the parent resumes execution. This is important for coordination. Now what happens when a process finishes? It calls exit. This tells the OS that the process is done. But here's something interesting. When a process finishes, it is not immediately removed from the system. It becomes something called a zombie process. This means it has finished execution, but some information about it is still kept. The parent process must call wait to clean it up. If it doesn't, the zombie process stays and wastes resources. Now what if the parent itself has already finished? In that case, another special process called init takes care of cleaning it up. Now let's connect all of this to something you use every day: the command line or the shell. When you open a terminal and type a command, like ls, what actually happens? The shell reads your command. Then it creates a new process using fork. In that child process, it calls exec to run the command. The parent shell then waits for the child to finish. Once the command is done, the shell shows the prompt again. This simple loop is how your terminal works. And this entire behavior is built using fork, exec, and wait. There are also some interesting tricks. For example, when you redirect output to a file, the shell changes where the output goes before running exec. So instead of printing on screen, the output goes into a file. All of this happens behind the scenes. So to summarize, system calls are the way programs interact with the operating system. Fork creates a new process. Exec runs a new program. Wait helps processes coordinate. And exit ends a process. Together, these form the foundation of how programs run on your computer. In the next video, we'll go deeper into how programs actually run on CPU. So make sure you subscribe, and I'll see you in the next one.